Kawasaki's engine brake control system, or KEBC, is only one of many technical features found on the Prairie 360 4x4 and 650. The Prairie 650 has a liquid-cooled, 4-valve, single overhead cam V-twin engine that develops over 40 horsepower at 6,500 RPM. Its over-square bore and stroke provides a user-friendly torque curve, while the 90-degree V-twin cylinders result in low engine vibration. The Prairie 360 4x4 is powered by a 362cc air-cooled single-cylinder engine that produces over 19 foot-pounds of torque. Both vehicles are equipped with a compact, fully enclosed wet rear brake system sealed from mud, dust, and water. The system uses a combination of friction and steel plates to provide consistent stopping power. To help meet the rigorous demands placed on the system, Kawasaki gear and wet brake oil must be used in the brake housing. When the terrain becomes difficult or muddy, a variable limited slip differential control provides extra pulling power. In four-wheel drive, the rider can pull a lever mounted on the left side of the handlebar, equalizing the driving force to both front wheels. This gives the vehicle increased traction, making it easier to overcome difficult terrain. The system is enclosed in a compact front differential housing and uses high-quality engine oil for lubrication. Be sure to use only the oils recommended in the service manual. Another feature to assist the rider in tackling difficult conditions is an electrically selectable 2- and 4-wheel drive system. With the flip of a switch, the system allows the rider to easily shift between 2- and 4-wheel drive, providing the vehicle with the extra traction needed to conquer rugged terrain. Kawasaki's automatic power drive system, or CAPS, ensures that the engine is always running at the most efficient RPM. Tips for the tuning and maintenance of the CAPS system can be found at the end of this video. The next part of this video explains the operational theory, construction, maintenance, and troubleshooting of the KEBC and belt failure detection systems. Kawasaki's engine brake control system is a supplemental braking system that provides the vehicle's operator with additional stopping power. When specific conditions are met, the system uses a controller to send a signal to an actuator. From this normal operation position, the actuator moves a lever assembly, which keeps the drive pulley's movable sheave from disengaging the drive belt. This is the engine brake on position. As a result, braking forces created by the engine compression are transferred through the CVT to the wheels. The system only operates at low ground speeds, from about 1.9 to 12.5 miles per hour, with the vehicle moving forward. The KEBC system has 5 main components: the controller, actuator, lever assembly, forward-reverse sensor, and a speed sensor. The controller is located under the seat. It detects the ATV's speed and engine RPM electrically, and when conditions are satisfied, signals the actuator to engage the system. The actuator is mounted on the CVT cover and consists of 3 parts: a DC motor, reduction gears, and a potentiometer. When signaled by the controller, the actuator moves the lever assembly. Installed in the CVT cover, the lever assembly transmits the force of the actuator to the drive pulley. The forward-reverse detecting sensor is located on the left rear side of the engine and utilizes a Hall effect sensor to read the pattern of the teeth on the rotor located on the bevel gear to generate a voltage signal. The controller then uses this signal to determine the direction of the ATV. The speed sensor is located on the right rear of the engine. It generates voltage pulses, which the controller uses to calculate the vehicle's speed. An additional component of the KEBC system is the multifunction meter. Located on the handlebar assembly, the multifunction meter displays a failure indication pattern in the event the KEBC's actuator fails. A special feature of the KEBC system is the learning control. This function ensures that the lever assembly maintains a consistent engagement point with the CVT. After the ignition switch is turned off and a prescribed length of time passes, voltage is applied incrementally to the actuator. The actuator then moves the lever assembly into contact with the bearing collar on the drive pulley and keeps moving until the movable sheave comes into contact with the drive belt. Once the lever's movement is stopped by the belt and a prescribed length of time passes, the voltage of the potentiometer that is installed in the actuator is recorded on the controller. The controller uses this value to help determine the new engine brake engagement point. When the engine is started, the learning control returns to normal operation. For more information on learning control operation, consult the service manual. Like other systems, the KEBC needs periodic inspection and maintenance. The service manual should always be consulted for proper servicing procedures. With the CVT cover off, inspect the contact surfaces of the lever assembly. Measure the contact surfaces. If the contact surface width is greater than 6 millimeters, replace the lever assembly. Check the contact surface on the drive pulley's bearing collar. If there are any signs of unusual wear, or if the bearing doesn't move smoothly, replace the drive pulley cover. If the CVT cover, lever assembly, or any of the CVT drive components need to be replaced, 2 measurements must be made before reinstalling the CVT cover. The lever assembly installation length is the distance between the CVT cover mating surface and the contact surfaces of the lever assembly. To make the measurement, remove the gasket from the CVT cover, then install the measuring tool. Make sure the ends of the rods are resting against the contact surfaces of the lever assembly. Measure the distance from the plate's deck to the rods. The standard measurement is between 1.33 and 2.47 millimeters. If the measurement falls outside of this range, replace the lever assembly. The lever assemblies come in 3 different contact surface thicknesses. Consult the service manual for proper lever selection. The second measurement is the installation length of the drive pulley. This length is measured from the surface of the crankcase to the bearing collar on the drive pulley cover. Install the measuring tool onto the crankcase. Measure the distance from the plate's deck to the bearing collar on the drive pulley cover. This measurement should fall between 14.55 and 15.65 millimeters. If the measurement falls out of the service limit, replace the drive pulley cover. The drive pulley cover comes in 3 different heights to allow for proper adjustment. Consult the service manual for proper cover selection. Like all technical systems, troubleshooting of the KEBC system requires careful observation of the symptoms. In the event the KEBC system fails, the multifunction meter will flash, alerting the rider. If the KEBC actuator has failed, the 2- and 4-wheel drive indication lights on the multifunction meter will flash alternately, in 1-second intervals. Consult the service manual for actuator service specifications and testing procedures. If the actuator tests good, continue testing each of the system's components using the information found in the service manual. Remember, when performing any electrical test, make sure the battery is fully charged before you begin. If the problem is found to be mechanical, inspect the actuator output shaft for damage, lever assembly for wear, and the CVT components and belt for signs of damage. To diagnose a problem with the learning control, test the actuator and controller for proper operation. A word of caution: when the CVT cover is off, avoid turning the key on, then off. If this occurs, the system will enter the learning control mode, and the lever assembly will move out until it reaches its maximum travel. This will cause the lever assembly to remain in its fully engaged position. To correct the problem, apply battery voltage to either the red or black lead pin on the actuator's 6-pin connector and ground the other wire. Stop applying power when the actuator returns to the engine brake off position. The belt failure detection system detects excessive drive belt wear or belt damage and will automatically signal the operator that there is a malfunction. A switch mounted on the CVT cover is contacted whenever the drive belt becomes excessively worn or begins to fail. Once the system is activated, the reverse light and LCD portion of the multifunction meter flashes at a high rate of speed. The system also limits the engine to 3,600 RPM. In addition, if the vehicle is in four-wheel drive, it will automatically try to shift into two-wheel drive in order to minimize the load on the drive belt. The belt failure detection system gives the vehicle's operator the advantage of preventing the damage that can be caused by a worn or broken drive belt. The belt failure detection system consists of 6 main components: the switch, switch circuit relay, system circuit relay, flashing relay, diodes, and the controller. The switch is mounted on top of the CVT cover. When contacted by the belt, the switch moves to the open position, activating the system. The switch circuit relay, system circuit relay, diodes, and flasher relay are all located on the right side of the vehicle under the air cleaner cover. Once the switch is contacted, it energizes the switch circuit relay, activating 2 circuits at once: the 2 four-wheel drive and warning display on the multifunction meter. When the 2 four-wheel drive circuit is activated, voltage is supplied to the system circuit relay, energizing the coil and closing the switch. This completes the controller's warning ground circuit, and if the vehicle is in four-wheel drive, the controller will automatically try to shift into two-wheel drive. When the warning display circuit is activated, voltage is supplied to the flashing relay from the switch circuit relay through the diode and then to the multifunction meter. During activation, the flashing relay opens and closes, causing the voltage supply to the multifunction meter to cycle. This causes the multifunction meter to flash a failure indication pattern. Finally, the controller recognizes the problem and limits the engine to 3,600 RPM. When troubleshooting the belt failure detection system, always check the drive belt condition before performing any other diagnostics test. If the switch has been contacted and the CVT cover is damaged, the cover must be replaced. When installing a new CVT cover, the drive pulley height and lever assembly installation length must be checked. If the drive belt is in good condition and properly adjusted, and the belt failure detection system switch has not been contacted, begin testing the system's electrical components using the service manual as a guide. A properly functioning CVT is essential for optimal KEBC performance. Procedures for the removal of the CVT can be found in the service manual. Be sure to inspect all components for wear and replace any part that falls outside of the recommended specification. Proper lubrication is critical for optimal CVT performance. Lubricants should only be applied to those areas specified by the service manual. Special attention should be paid when installing the pins in the driven pulley. Before installing, lightly coat each pin with molybdenum disulfide grease. Once the sheaves are assembled, install the pins and apply 1 gram of grease into each of the pin openings. Using too much grease in the pin openings may allow grease to fly out onto the sheaves. As a result, the drive belt may slip, causing poor vehicle performance. Grease also catches dust and dirt, which may prevent CVT components from operating smoothly. Another area to pay special attention to is the spider shoe side clearance. With the drive pulley cover installed, measure the clearance between the shoe and the post with a feeler gauge at 2 different positions. Standard clearance is greater than 0 to 0.12 millimeters. If any of the measurements are greater than the service limit, replace all the shoes with standard size shoes, then recheck the clearances. Shoes still not meeting specifications can be replaced with a different size shoe by following the clearance chart found in the service manual. The drive belt should be inspected every 90 days or 1,100 miles, more often if the vehicle is subjected to hard usage. Check the belt for cracks, breaks, or peeling. If the belt is in good condition, measure the width using the special belt measuring tool and replace if needed. To measure the drive belt deflection, place a straight edge across the drive belt between the drive and driven pulleys. Now, using a sturdy ruler and no more than 13 pounds of force, push the belt away from the straight edge and take the measurement from the ruler. The belt deflection should be between 22 and 27 millimeters. If needed, consult the service manual for drive belt adjustment procedures. The CVT can be tuned for high altitude or special operating conditions. Tuning the CVT is done by changing the ramp weights or adding a spring shim in the drive pulley. Lighter ramp weights apply less force to the sheave, changing the backshift characteristics of the CVT. In addition, a shim installed under the drive pulley spring provides more force for the ramp weights to overcome, slowing the belt's progress up the sheave. For more information on tuning and servicing the CVT system, consult the service manual or the training video entitled Kawasaki Automatic Power Drive Systems. In this video, we have covered what the KEBC system is, how it works, its components, and troubleshooting of the system. In addition, the video explained the workings and troubleshooting of the belt failure detection system. Finally, we explored tips for the proper assembly, adjustment, and tuning of the CVT drive system. The video reference manual covers what you have just seen, with added detail.